So today's main objective, WheatStone, okay, a pakka 5 markers. Maybe in the unit test or in the board exam you can get it. Correct. So in the last session I told about what KCL and KVL. So you'll be applying KCL in this. So KCL is nothing but I'd just draw some two lines randomly. Correct. Then I will draw what I1 and I2 going outside, I3 and I4 coming inside. This is my junction J, junction or node, whatever it is called. So KCL is nothing but what? Which are the currents coming inside the junction? I3 and I4, correct? Which are the current leaving the junction? I1 and I2. So this is nothing but what? I3 plus I4 is equal to I1 plus I2. This is my KCL. So with this, I'll just start it. So one more thing is KVL. Let me see that whether it is there. Yeah. KVL in the sense sum of voltages is equal to 0. Just remember, sum of voltages is equal to 0. Sum of all the voltages equal to 0. That is my KVL. So if I take this network, I'm not sure whether it is, whether you can see, I think everyone can see it. Let me just snip this thing. Yeah, I think now I think everyone can see it more clearly. So this, if I want to write here, what is the keyword here? Sum of all voltages is equal to 0. Correct? Yes. And here if I want, I can see here voltage is in what? Clockwise direction. Voltage is in clockwise direction. And this is my negative terminal, minus plus. Correct? Minus plus. And for all the resistors in all the problems, for all the resistors in all the problems, whenever it is in clockwise. So this won't be taught in school. Okay. So this is my plus minus, right? Correct? Plus. Here also you put plus, here also you put minus. In the resistors, whatever is the battery charge first. Plus means you have to put plus, minus. And whichever is the leaving group, very important, kindly here. Whichever is the leaving. Here the leaving group is which one? The leaving group is minus. Correct? That symbol I have to put. For example, if I want to take in this question, and I'm putting what? Minus and plus. Here I have to put what? Plus and minus. Correct? So when I write something here, I'll write what? What is the leaving symbol here? Plus. So plus E1. And for R1 it is plus and minus. Correct? And this is my voltage drop. So minus V1. Minus V1. And if I want to come here, again this is what? Plus minus. Plus minus. Plus and minus. But if I see the current direction here, what it is? It is opposing. It is opposing. I'll write down here in words. I2 is opposing. Very important. Huh? I2 is opposing. What? V2. I2 is opposing V2. Normally, what I will write here, normally according to this thing, if I want, let me just show you spotlight. If I want to write for this V2 plus and minus, normally what I'll write here minus V2, right? But here you can see the change, minus plus, and current is flowing in opposite direction. So it will be what? It will be again minus of the V2. It will be again minus V2 since it is opposing. So here plus E1 minus V1 plus V2 it will come. It won't be minus V2, it will be minus of minus V2, it will be plus V2. Correct? And again here plus and minus. I'm taking everything in what? Clockwise direction. Plus minus in the sense it will be minus E2. Plus minus in the sense minus E2 is equal to 0. So I want everyone to write down this thing as it is very important. The diagram and all I'll share it to you. Only write down what I have wrote in red. And main thing is I2 is opposing V2. Maybe I'll take a screenshot of this. Let me, yeah, the snipping I will take it. I'll save it and I'll share it with you. So don't worry, I will save this snipping thing here, okay? I'll save it all. I will save it. Yeah. Now let me come back to the main thing of today's topic. I'll just close all of these things. Just let me save this. Yeah. Now I'll come back to the original thing. The Wheatstone bridge. Okay. Wheatstone bridge. This is the most important 5 marker. Correct? So before learning what is a Wheatstone bridge, we should know why we are learning it. Correct? What is the purpose of Wheatstone bridge? Yes. So basically, everything is used to what? It is used to find the resistance of the wire. Resistance of a wire. Or to compare resistance of 2 wire. That's it. That is the main purpose of Wheatstone bridge. Wheatstone bridge. To compare resistance of wire or compare the resistances of 2 wires. That's the main purpose. Now, in this, we have to prove what? P by Q is equal to R by S. We have to prove what? P by Q is equal to R by S. So P, Q, R and S are what? Resistance value. Resistance value. Okay, so this is what we have to prove in the Wheatstone bridge. Now I think everyone can see this. Yeah. Now I'm going to apply here KVL. What I'm going to apply here? KVL. So this is a very simple diagram. So don't worry about the diagram first. So kindly try to understand what is happening with the diagram. So this is in what direction? clockwise direction. I will start from this clockwise. So what I told you, put plus and minus, put plus and minus. Correct? The leaving group is what always? Plus, and leaving group means negative should come. And always draw a triangle. What's the triangle here? V is equal to IR. V is equal to what? IR. I is equal to what? V by R. Or V is equal to IR. So what is my resistance here? P. My resistance is P. Correct? The leaving group is minus. So minus I1 into resistance P. Again, I'll go down here. Correct? Again, I will go down. That is towards this IG, galvanometer thing. IG is called galvanometer. It shows the deflection of the current. The use of galvanometer is what? To show the deflection of current, whether it is negative or positive current or whatever it is. You got the point? It shows the deflection of the current. You got the point? Deflection of the current, only IG is used. Now, here also, but we got something called G. This capital G is also called galvanometer resistance. So which are my resistances? P, Q, R, S and G. Correct? Here also I'll mark as what? Plus and minus. The leaving group is what? Minus. The current direction is same as the leaving group. So minus IG into G. Minus IG into G. Correct? Then I will go through this loop. So I'm taking the triangle ABD. This for triangle ABD. ABD loop. A, B and then D. ABD loop. Then here also I'll mark plus and minus. Then again I'll put what? Minus, minus. What is here? I2R, right? Minus I2R I will put. Minus I2R I will put. But see the direction of I2, it is just like the previous thing what I just mentioned. I2 is what? Coming the opposite direction, in the sense minus I2. So minus minus plus I have to put. Minus minus I have to put plus, equal to 0. Equal to what? 0. So minus I1P minus IGG plus I2R equal to 0. Fine. So normally in the balancing, I'll take what? IG, my galvanometer current is equal to 0. I will take IG is equal to what? 0. Fine. And similarly, I will find it for what? This loop BCD. BCD, the triangle BCD is there, right? For this also I'll find BCD also I will find. So here what is it for BCD? I3Q. Correct? Again put here plus and minus. Here also plus and minus. Correct? Everything I'm taking clockwise. Then galvanometer G will become what? Plus and minus here. Plus and minus. Correct? Yes. So how will I write this? Plus minus in the sense I have to put minus. Minus I3Q. Minus I3Q. Then along CD it is plus and minus. But current I4 is what? Current I4 is in opposite direction. So plus I4Q. Plus I4Q. Correct? Plus I4Q. Then we'll go to what? Top. Then again it is opposing. Then again it is opposing here because IG is coming in opposite direction. So plus IGG. Plus IGG equal to 0. So this is for the loop BCD or BCDB. Yes, correct. And for everything, wherever Ig value is there, you have to substitute 0, because I told you Ig value should be 0 for balancing the circuit, because galvanometer current should be 0, because if galvanometer current is not 0, then there will be deflection, then I can't measure the resistance value properly. Okay, fine. So this is what the same thing which I written here. Correct. Instead of I4 and all, they are given some other value. That's it. Some other in the sense, I written here I3, I4 is there. No, what is my I3? I3 from this is what? I3 from this is I1 minus Ig. I4 is I2 plus Ig. All of these things are substituted in the below. Okay. So once we do it, we'll be getting this equation. Minus I1 cube plus I2 is equal to 0. Correct. So here I'll be getting what I1 P is equal to I2 R is equal to 0. So what I can do is I can take I1 by I2. Then I'll get P by Q is equal to R by S. That's all. P by Q is equal to R by S. So I compare these two equations, 2 and 3, whatever it is. Or 2 and 4. 2 and 4, if I compare, I will get the equations. Now the next one is potentiometer. Okay, but I think before potentiometer, I think we got meter bridge is there. After WheatStone bridge, we got something called meter bridge. What is my P and Q? Resistances. Correct. If total scale is 100, this will be my L. Correct. AD will be my L. So DC will be my what? 100 minus L. Only this thing we have to know. So just write on P by Q is equal to R by S. What is P? Length. Correct. Length of wire AD. Q is again length of the wire, resistance wire, 100 minus L. P by Q is equal to L by 100 minus L. What is P by Q is equal to? R by S. This one, the one which you just derived. So R by S is equal to L by 100 minus L. Multiply by this S into here. SL by 100 minus L. This is not by 1 minus L, this is by 100 minus L. Okay, the printing mistake. That's it. So it's all for the determination of resistance. That's all.